Hey guys, this video is for the hypothesis test of a mean, which we did yesterday on the 14th, in case you missed it. So if you have not already, please pause this video and copy down these notes onto your paper. Please don't do it while I'm talking so that way you can listen. I'm going to try and keep the video short. So pause this right now, copy this down. Okay, so we're doing the hypothesis test of a mean, which could actually be two different tests. It could either be a z-test or a t-test. Now, whether or not it's a z-test or a t-test depends on which standard deviation you're given. This is the same as it was when we did confidence intervals. So if you're given sigma, which is the population standard deviation, you're going to want to use a z-test. If you're given S, which is the sample standard deviation, then you're going to want to use a t-test. Okay, for the purposes of this, we're going to be doing a z-test to start, and then afterwards we'll do some t-tests as well. So this problem says the average cost for a year of college is $32,562 with a standard deviation of 2103. Has this average changed? I sample 68 schools and find the average to be 32,010. So the first step is check the conditions. You guys know we've been skipping that for now. We're going to continue to do that till we get through all the different types of tests. So basically, first thing I would do is define my variables. It says the average cost for a year of college is $32,562. So obviously that's a mean because it says average, but you need to know which mean is it. Okay, let's define the two types of means that we have. We have mu, which is the population mean, and we also have x bar, which is the sample mean. Okay, so you have to read the question to find out which it's talking about. There's no shortcut to figuring out which it's talking about other than you want to know what the subject of the sentence is. So this is talking about the average cost for a year of college. So that would mean like out of everybody who goes to college in the world, the average cost is 32,000. So that's talking about the population, not the sample, because the sample would state that there was a certain number of people they asked to get that mean. So this is going to be your mu, 32,562. And then let's keep reading. It says the standard deviation is 2103. Notice this standard deviation is in the same sentence as mu. So if you are thinking about this sentence, the subject of the sentence was the average cost for a year of college. So it's talking about all colleges. It's not talking about a sample. There's no mention of a sample in that whole sentence. So which standard deviation is this? Well, I just said it's not the sample, so it must be sigma. So in this case, we have sigma, not S, and our sigma value is equal to 2103. After that, basically we'll find N, which it says I sample 68 schools, so N should be 68. And then X bar is the mean of the sample. So it says I sample 68 schools and find the average to be 32,010. So this mean is referring to the 68 schools that have been sampled. So that would give you X bar, 32,010. Okay. Now remember your hypotheses should be about the mean. So you want to read the question again, and it says basically they want to know if the average has changed. So your HO would be that the average has not changed, or in other words, the average cost to attend college is still 32,562, and our HA, we're going to say the average cost. These quotes just mean that you're repeating the same thing. To attend college has changed, because that's what the hypothesis is. Even though it's clear in reading our X bar that it's gone down in our sample, the hypothesis is that it's changed. Sorry if you can't see that. It says has changed. So since our hypothesis is that it's changed, we need to make sure that that's what we put here, not that it's gone down. Okay, let's also write it in symbols. So the first one would be that the mean is equal to, still, 32,562. And the second one would be that the mean is not equal to, because we're claiming it's changed. We're not claiming we know which direction it's changed. Okay, so that would be our hypotheses. So now I'm going to go to the next page. If you guys could pause this video right now and copy this part down, I'd appreciate it. Okay, so this is the part I really hope you guys have copied this down and you're able to listen, because some of these steps, like you've seen before. So this formula is the same. We had sigma instead of s, so we're going to put our sigma on top over the square root of n, and this is what I got for the standard deviation. Okay, normally we go up and down by our standard deviation on our chart here. However, I'm trying to give a shortcut because that takes forever and it's really tedious. So because we're this far into the year, I mean, we're practically graduating, we're just going to start doing it by z-scores. Okay, so what I did next was calculated the z-score using the formula, and I got negative 2.16. I put that here because this is the mean right there, and then I went -1, -2, and a little bit further. So that's where I got that from. Okay, so that's the line, negative 2.16. Again, I started at the mean, and I went 2 standard deviations below, plus a little bit more for the 0.16. That's where the line goes. Now, why the heck did I put this one on the other side? Well, that goes back to your alternative hypothesis, because remember, that tells you which way to shade. So in this case, we see a not equal to instead of a less than or greater. So how the hell are you going to know which way to shade if it just says not equal to? Well, the answer to that is you have to shade both ways. So what I did was I basically took the absolute value of this z-score, or the opposite really. So if it was positive, you need to get the negative one. Same number though. If it's negative, you're going to take the positive one, and you're also going to add that line onto your chart. And then you're going to shade in the direction of the tails. So we call this a two-tailed test, meaning you have to shade both sides because your hypothesis doesn't claim to know whether it's greater or less. So you're going to take into account both situations. So what I did then was I looked up this z-score in the chart. I highly recommend you look up the negative one. If you look up the positive one, you're going to have to subtract by 1. So it's just easier to look up the negative one, so that way you don't have to subtract by 1. If you look this up in the chart, you would get 0.0154. Now you could do the same here. Look this up in the chart and subtract by 1, and I promise you would get 0.0154. However, you also know that this normal curve is symmetric. So therefore, if this is 0.0154, this side should be literally exactly the same because of geometry and symmetry. They have to have the same area. So what I'm doing is, to find the total shaded area, I need to take this and add it with this because, they're both shaded. So to get the total amount, you would just add them together. Okay, so once I did that, I got 0.0308, and then I need to compare my p-value to my alpha. So what I'm doing is looking at p, looking at alpha. Our alpha, it didn't state what alpha was in the problem. If it ever doesn't state it, always use 0.05. That's just a statistical rule. And here we've got 0.0308. It appears that p is less than alpha. 3 cents is less than 5 cents. So because of that, here I wrote down the rules again. If p is less than alpha, you're going to reject HO. If p is greater than alpha, you're going to fail to reject. Remember, if you reject HO, in other words, if you reject HO, then you have evidence to reject HO. So you're not going to reject them unless you have enough evidence. So anytime you reject it, it means there is enough evidence. If you failed to reject, you'd say there's not enough evidence. And then I just put in my HA, which was to show that the average cost to attend college has changed, which is your HA. So your final answer, you just give your sentences. I'll be on tutoring today. If anyone needs help, please feel free to reach out over Remind as well. Okay, see you guys later. Hope you're doing well.